And this way you get to stay ahead of everyone else because it'll basically be like getting yourselves ready for term 3. Okay, we are going to jump into a recap of what we did on Tuesday. Now, if you're brand new today and you have not done trig functions in class, then this may look a little bit scary. Please don't panic. We're going to try and break it down into like little manageable pieces. Okay, so let's have a look. Well, I've said plural here. I keep on lying to myself in my own notes. My mic. Okay. Draw graph. We're going to work with some English grammar issues here. Draw a graph of the following function. For the interval, this is really what I care about. For the interval, x is an element of negative 360 to 360. Can anyone tell me what that actually means? What does what I've highlighted mean? Anyone help out? I'm happy with whatever you think it could mean. Right, wrong, tell me your guesses. But what do you think what I've highlighted means? Okay, yeah, it's the domain. Great. It's the domain that we care about, and we know it's a domain because they're talking about x. Okay, and so basically they're telling us what x values we are going to plot for. We want to plot this graph all the way from negative 360 to 360. They're telling us what x values they want. Okay, when you're given an interval like that, that's what it's telling you. It's telling you what x values they want. It's the domain that they want. Okay, so they want you to plot from negative 360 to 360. Next thing we need to just read carefully. Ensure that all intercepts with the axes, so your x-intercepts and your y-intercepts are labeled, and your turning points are labeled. Okay. Now, you won't be given this table that I've drawn over here. So let's just sort of break down how you would do that by yourselves, because you'd need to know what you're doing. You're going to make sure that you have your whole domain covered. So they wanted from negative 360 all the way to 360. And when we're dealing with sine, when we're dealing with sine or cos, we jump in 90 degrees. Okay? We always jump in 90 degrees. So if you were making this table by yourself on your test or piece of paper, you would be doing jumps in 90 degrees. Okay. What I would love at this point in time is for you to draw yourselves a set of axes, so just a y-axis and an x-axis, and make sure you have the important points. And important points, I mean negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270, 360. So I just care about those points, and I care about these points up here, 1, 2, 3, 4, and down to negative 4. Okay? I'd like you to draw yourself a set of axes that look like that. And then I would like you to fill in what these different values for y would be if we were looking at the equation y is equal to 3 sine x minus 1. So I'm going to help you with the first one, and then I'm going to let you go free with this. And then I want to see what your graphs look like. So I want you to hold them into your cameras. Okay. So for those of you who weren't here on Tuesday and are feeling a little bit overwhelmed, grab your calculators. Okay. We're wanting, they will always give you the equation if you're wanting to draw. Yeah. Okay. So we're wanting to find out what my y value would be if my x value is negative 360. So in our equation, we're going to say 3, so it's on our calculator, 3 times sine, and now in brackets, our x value is going to be negative 360. Negative 360, make sure you close that bracket, minus 1 is equal to, and I get a value of negative 1. Okay, so I want you to fill in all of these different values on your side. And then I want you to draw yourself the graph. So I would like you to draw the graph. Sure. So in your calculator, Simkelo, you're going to, basically we're using this equation over here, what I've got in my big cloud. Okay. We're trying to find the y value when our x value changes. So our y value is going to be equal to 3 times sine, in brackets, we're going to put our x value. In this case, it's negative 360. Close that bracket off, and then we're going to minus 1. And you should get the answer of negative 1. And then try for negative 270 and negative 180 and negative 90 and 0. Try for all of them and see where you get to. And basically, you're slowly going to want to fill in all of these answers. I'm just going to give you a moment to draw this. You're getting a 0 for the first one. Okay. Just make sure that your calculator looks exactly like this. 3 times sine negative 360 minus 1. Make sure it looks exactly like what I've done in blue over there. If it doesn't look exactly like that, then something will go wrong. Josh, can you do me a favor? Can you tell me if your calculator at the top, if it's got an R or if it's got a D in that top line on your calculator? Has it got an R or has it got a D? Okay, then you should be getting the right answer. Are you closing your brackets off? Do you have this bracket that closes off the angle? Okay, so in your calculator, it looks exactly the same as that. Then you should be getting the right answer. If you've got a D happening at the top, and it looks exactly the same as what I've written over there, and make sure you're writing the negative 360, not positive 360, you should get the answer of negative 1. Come on, Gail. Oh, you can't hear me. Yeah.
The setting is the same on the computer and on the phone, right? Should be.
I think so. But I think that probably the easiest thing would be to leave the chat and come back in.
Thank you.
Okay, you definitely shouldn't get a math error for negative 270. So I think what happened there is you didn't close the brackets. Okay, I would like to start seeing some of your graphs. So once you've got your graphs ready, just hold them up to the camera for me whenever you feel comfortable. Tabiso, what is going on over there? It's like, there's quite a situation happening with the tissues. Okay. Is it allergy related? Yeah. Okay. Okay, let's have a look what some of these graphs are looking like. Oh my goodness, Canva, something has gone terribly wrong because it looks like the Drakensberg mountain range instead of a wave. We always need to have the same maximums and minimums. We've taken a terrible detour, terrible detour. Oh, Canva, that may be my favorite sine graph I've ever seen in my life.
And PUA, I see yours, girl.
Okay, a PUA, that is, just keep on looking at Canvas. A PUA that's looking solid. You've got your max of 2, which I like. You're going down to -4. That's looking solid so far. Up here where I'm liking it. I think we need to work a little bit on your curves, but otherwise I like it so far. Kamogelo, that's looking good so far. Georgia, Portia. Yeah, Portia, just be careful. So it's a good shape, but you're going a little bit too triangular. So try and keep it with a little bit more of a curve. Kaylee, that's looking good.
Sorry, you guys skills.
You're the other side of the Drakensberg mountain. We need to put yours together with Canvas, and we have the full Drakensberg set of mountains going on. we've gone very off track on the right hand side of the graph.
You guys have some joint skills, guys. I'm proud of all of you.
Yeah, if we take Canvas right outside of his graph and we join it with your left hand side of the graph, then we will have a good sine graph happening. I like it though. I love it. I love it. Okay, Ria, that's looking solid. I'm enjoying that. And I like the curves happening. Unati, something's gone awry. I see that it looks almost like a heartbeat happening. Just to the left of the y-axis, something has gone wrong over there. Bukle, I like the points that you've done, but the curves, we need to try and get them to look a little bit more signy, but I'll show you how to do that now. Isvile is sort of the same as Bukle. There's some good things happening, and then there's some things we need to work on. Yeah, Zandisile, that's much better, much better. Just remember to keep the lines going with little arrows. Ortile, yeah, it's a little bit triangular, but something we can work on. Mostly, I'm liking what I'm seeing, and you've given me a really good laugh, which I appreciate. Okay, let's see if we can draw this up. So those of you who are still feeling a little bit lost, let me show you what we should be doing. Okay. Ooh. Sorry, just move that around. Go back to where we were. Okay, cool. So let's try and break this down. So at -360, we saw that our answer was -1. Then for -270, our answer was 2. Then we have -1 again. Then we have -4 for -90. For 0, we have -1. Then we have 2. We have -1. And then we have -4. And our last one here is -1. Okay, so if we were to plot these points, if we were to plot them, let's see what that would look like. So we would have -360 and then -1. So that would be over here. -270 and 2. -180 and -1. -90 and -4. 0 and -1. 90 and 2. I'm just going to get rid of these highlights because we don't need them anymore. Okay. 180 and -1, and then 270 and -4, and 360 and -1. Okay, so if you got those points, that's great. Now to work on your curves, when I was saying it looks a little bit too triangular, we don't want it to look like that. Okay, we don't want it to be like a peak. We want it to have a nice curve, and then we turn there, and we turn again, and we turn down, and we turn up. And we turn around, and then we turn down, and we turn up, and we want to put little arrows on the ends of our lines. Okay, then we need to make sure we answer the question. So we need to make sure we've given our intercept points. Okay, so that one is going to be 0 and -1. Now this point over here is not one that we had to find. It's not an easy one to give, so we're not going to give those ones. We would only have to do that when we get into grade 11, so don't panic about them just yet. We're only going to give the ones that are easy to give. Yeah. So the Drakensberg Mountain, some of you were like coming like down and then going up. Basically what I mean is your maximum points always need to be the same and your minimum points always need to be the same. No, Canva, I loved your graph. I've been having a really horrible day and your graph actually made me really happy. So it was beautiful. Okay, and then we need to give our turning points points. So this is going to be -90 and -4. This up here is -270 and 2. This is going to be 270 and -4, and this is going to be 90 and 2. Okay, so basically we just give our turning points and our points of intercept with axes. Cool. So if your graph looks like this, then that is great. Let's try and answer some of these questions. It'll make the rest of this lesson a little bit easier. What is my maximum value? What is the maximum of this graph? What is my maximum value? 2. Beautiful. Okay, so we always look for our maximum value is our y value. What is our minimum value? Good, -4. Nice. Okay, now knowing those, we're able to work out our range. What is our range? How would we write our range over here? So remember, your range is going to include your minimum and your maximum. Always start with the smallest thing you can be and move to the biggest. And it is allowed to include it, okay? Do you see how it is allowed to be -4 and it is allowed to be 2? So we're going to write square brackets, -4 to 2. And the reason we have square brackets is because it's allowed to be -4 and it's allowed to be 2. They're not asymptotes. Okay. What is my period? A period is how many degrees does it take to do a full curve? It takes sine and cos 360 degrees to have a full curve. What is your amplitude? Now your amplitude, you can just have a look at your equation. Beautiful, nice guys. I feel like Tuesday is like solid in our heads. Our amplitude is, this is our A value, which is our amplitude. Our amplitude is 3. Nice.
Well done,
okay, cool.
guys. Oh.
So, some of you stuck around for the end of the lesson on how to do this on your calculator. -1. But I want to show you how we can do this on our calculator if you didn't stick around. Okay, so I just want everyone to get an idea. So make sure you have your calculators out. This is like a little trick to make your lives a little bit easier. If you are wanting to get the coordinates on your calculator, we're going to follow a couple of steps. So grab your calculator and I'm going to go through the steps really slowly. So, but if you just let me know if you need me to stop at any point. Okay, so first thing we want to do is we want to push mode. So where it says mode or setup. Okay, and we want to be in table mode. So whatever number is equivalent to your calculator where it says table, mine is number 7. Can you let me know what the other Casio calculator's number is for table? Is it also 7? 3. Okay, so you'll push 3. You'll push 3 for table. Okay, so you're going to push 3. Then on your calculator, what you should have is, at the moment it will be written as f of x is equal to, okay? And you are going to write in the equation that we care about. So in this case, we are going to write 3. So you're going to type in a 3. Now we need sine. So you're going to write sine. And you'll see it opens brackets. Now we need to have an x. In order for us to have an x, we need to push alpha, which is in pink. And then we're going to push the X button, which is just above the bracket. And that's going to give us our X. So you're going to push alpha, and then you're going to push the X, and you're going to then put the bracket to close it. and type -1. Okay. Now you're going to push equals. And then on your calculator, it's going to give you the option of g of x, and we don't have a g of x, so we're just going to push equals again. We're just going to push equals. Okay. Then your calculator says start question mark. That is saying what x value to start at. So if we have a look up here, what x value did we start at? What was our first x value? Good, -360. Excellent. So our first x value was starting at -360. That's what we're going to type in. So we're going to type in -360 and we're going to push equals. Now it's going to depend on wherever you are starting that graph. So it depends on what domain you are given. Okay. Then it says end question marks. And end is which x we want to end on. We want to end at 360. So we're going to write in 360 and push equals. Okay. Then it's going to say step question mark. The step is saying how many degrees do we want? So basically how many degrees is it between one point and another? And in sine and cos, it's always going to be 90. So we are stepping in 90 degrees. That's what it's talking about. So how many degrees is it from one point to another? Okay, so our step is 90. And that'll always be the case for sine and cos. And then you push equals. And you'll get an entire table with your x values and your y values. So on the left-hand side, you've got your x's. On the right-hand side, you've got your y's. And you can use your down arrow to go all the way to the end, which will be 360. And those are the coordinates that you would then plot. So the things that would change here, this works for every function. You can do it for parabolas, you can do it for straight lines, you can do it for anything. The thing that will change, the thing that we need to be careful about is the start and the end. So the start and the end depend on what domain they want. Okay, so they wanted us to start at -360 and end at 360. So that depends on our domain. The step is always going to be 90 in grade 10. In grade 11, that changes a little bit. And otherwise, we would just, this equation is going to be whatever the equation is that we're putting in. Hopefully that helps. And if you're needing to go through this again, you're welcome to rewatch this video and go through it a bit slower. But now it's here, so you can always rewatch when you need it. Your calculator can do amazing things. Amazing things. And if you have the wide calculator, then it can do even more amazing things. Then it can factorize all your things for you. It's crazy. Okay, cool. So on Tuesday, we looked at drawing it. Now we're going to be trying to find the equation of the graph, this one. So it looks like this. Canva. It's also the Casio. It's the white Casio. The FX991ZA. No, so it can factorize your trinomials for you. That's what it does. And it can solve simultaneous equations and can do all kinds of things. It's a very sneaky calculator. All right, let's get into this. So we have got y is equal to a sine x plus q. That is our normal sine graph equation, okay? And we're trying to find a and we're trying to find q. So let's have a look at this. Remember, q is how much it has shifted up or down, okay? Yeah, simultaneous as well. And in sine graphs, I'm just going to draw something for you so you can, if I had to draw a normal sine graph, it would look like this. Okay, That's my regular sine graph. So that's saying that nothing has shifted. My amplitude is 1. Nothing has moved. Okay, that's if I was to just draw my normal sine graph. So if I was looking at that as my normal sine graph, can you tell me how much my sine graph has shifted? How much has it shifted up? 2. Beautiful. Okay, so in a sine graph, at 0, your sine graph is 0. Okay, so we can just look at what our new y-intercept value is to see how much the shift is. Or you could just draw yourself your normal sine graph in pencil, and then it helps you see what's going on. Okay, so I can see that I've shifted up by 2, which means that my Q value is 2. So I know that y is equal to a sine x plus 2, because I know that I shifted up by 2. Awesome. Now I need to figure out what my A is, and your A stands for your amplitude, okay? How do we figure out amplitude? Who remembers from Tuesday? How do we figure out our amplitude? Who remembers how we figure out amplitude? It involves maxes and mins. There we go. Max and min divided by 2. Beautiful. Okay, so we take our max, we minus our min, and we divide that by 2. So our max over here is 2.5. Okay, we're going to minus our min, which is 1.5, and we're going to divide that all by 2. Okay, I just want you to go through this on your calculator, so because I don't want you to make silly mistakes when you get into your exams. When we have a mixed fraction like this, we have to be really careful with how we put that onto our calculator. We can't write 2 and then the fraction key, because it's going to give us the wrong answer. So if I'm wanting to put all of this into my calculator, I'm going to push the fraction key once, so I get a fraction. Then I need a fraction, a mixed number fraction happening at the top. So we're going to push shift and then the fraction key. And then you'll see that you get, so if we push shift and then the fraction key, you'll see on your calculator, you've got 3 blocks. It should look like that. And that's what we want when we want a mixed number. So whenever you have a mixed number, you need to do this. Otherwise, you're going to get the wrong answer. So the 2.5 is my top y value over here. So those coordinates up there would be 90 and 2.5. And this minimum value here would be -90 and 1.5. So our maximum value is 2.5 and our minimum value is -1. So I want you to try and put this into your calculator. Try and get that calculator practice. It's very irritating when you lose marks because you're not using your calculator correctly. So let's make sure we're all using them correctly. Beautiful, Portia. Nice job. The answer is definitely okay. So for the max and the min, we just look. We look at where our maximum point of our graph is and where the minimum point of our graph is. So our maximum point of our graph was 2.5 and the minimum point of our graph was 1.5. If we put this into our calculator exactly like this, is 2.5 minus 1.5 over 2, we get the answer of 1/2, which means our amplitude is 1/2. Now, I really want to make sure that everyone's putting this into their calculators correctly. So I want us to just spend a little bit of time here. Make sure you push your fraction key. So have your fraction key. And then you need to get the shift fraction key to get your mixed number. Then you're going to put the 2.5 in. You're going to subtract shift fraction 1.5. So it should look like that. I don't think the screen is light enough for you to see, but hopefully. And then down at the bottom, you're just going to write your 2, and you should get the answer of 1/2. So make sure you're putting this into the calculator exactly like that.
So Kamba and Lunelo, you still have to try it. So try what teacher Jenny just explained now.
Yeah, give it another go. See if that helps a little bit. Emmanuel, how can I help, sweetheart?
Hello, ma'am.
Hi.
Ma'am, I wanted to ask, ma'am, can't you just put 2,5 minus 1,5 instead?
100%. 100% you can do that. 100%. I just wanted to take this opportunity to talk about mixed number fractions because I know you guys are writing exams this week and next week. So in case you have fractions that pop up in your exam, then I thought I could kill two birds with one stone.
Okay, thank you, ma'am.
Sure. Nice job, guys. You've got there. Oh, that's awesome. Okay, so that's telling us our amplitude, and our amplitude is A. Okay, the next thing that we have to look at, which in this case isn't a problem, is we have to say, is our graph first going up or is our graph from that point going down? So we look from the y-axis. Is our graph from the y-axis, is it going up or is it going down? And it's going up. And because it's going up, so my graph is going up, which means my A is going to be positive. Okay, and so this is what we found is our A. And so now we can write our whole equation, y is equal to a half sine x plus 2. And that would be our whole answer. But I'm going to show you one where the graph goes down just now, so you'll see what's going on. And now these questions are really easy for us to deal with. So I'm just going to move this guy so it doesn't confuse anyone. If I had to give my amplitude, what is my amplitude of this graph? Don't overthink it. What would be my amplitude of this graph? Careful, careful. A half. Good. Okay, it's always going to be this. It's going to be our A value. That's going to be our amplitude. Okay, and our range, what is our minimum value? What is our maximum value? What is our minimum? Good, 1.5. What's our maximum value? Yes, and that's where we would end it. Okay, so our amplitude is a half, our range is 1.5 to 2.5. Beautiful. Nice. Not so bad, right? And this is, we went through this one really slowly. For lots of these, you can actually just see. I'll show you some tricks. Okay, let's have a look at this one. So let's start by finding our max and our min. Okay, so over here, this point over here, that's our maximum point. That's negative 90 and 1.5. And this is our minimum point, which is 90 and negative 0.5.
Sorry, Teacher Jenny, they didn't take screenshots.
Oh, sorry.
Go back. Yeah. Screenshot time, guys.
Oh, the YE, that stands for Y is an element of. So it's saying basically it's just fancy math language for saying that Y is one of, it's between these two numbers. That's what that means. Khabo, how can I help? You just need to unmute on your side. Okay, I'll try a bit later. Okay, so we've got our maximum value here and we've got our minimum value here. That's our first step. Okay. I'm going to show you a little trick that kind of helps with everything. But you may panic about it, so you don't have to do this. I just find that this is helpful. Once you've found your maximum and your minimum point, if you take your ruler, okay, so take your ruler and you literally draw a line through the center of the graph. Okay, so if you draw a line through the center of the graph, that tells you everything you need to know to find the equation of this graph. And I'm going to show you how. First of all, it tells us our shift. So in sine, the middle of the graph should be our x-axis. But it's now moved up 1, which means my q value is 1. Okay, so by drawing that line, we can already see that our q value is 1. The second thing that drawing the C key line does is it actually tells you your amplitude. If you go from your line...
Sorry, Teacher Jenny.
Yeah.
I see. Is that a half instead of 1? Or am I mistaken? The ship has moved because the 1 starts from the second.
Oh, sorry. No, you're absolutely right. You're 100% right. Sorry, I was not paying attention. You are 100% right. Thank you. Thank you. Yes. And important. Absolutely. Yes. Okay. The second thing that this line does that's nice and sneaky that helps us is that we can go from the line to our maximum point, and that just tells us what our amplitude is. So if we go from 1/2 up to 1.5, then we can see that our amplitude is 1. So the difference between 1/2 and 1.5 is 1, which means A is equal to 1 sine x plus 1/2. So basically, you can do this straight if you can draw the line through the center of your sine graph. So basically, you're finding your symmetry line. You're able to sort of find everything you need. You're able to find your Q value because you're able to see how much it's shifted up, and you're able to find your A value because it's from that line to the maximum line. Just a sneaky way of doing it. You don't have to do it this way. It just makes life a little bit easier. But let me show you how to do it if we were going through it, how we did the last one. Okay. First thing that we would think of is that if we were drawing our normal sine graph, we would know that sine of 0 degrees is 0. Okay, so our sine graph always is at 0. And now our sine graph is at 1/2, which means that my Q value is 1/2. Is everyone happy with finding that 1/2 part of the equation? Let me know. If you're not happy, it's okay. You just need to let me know. Okay. So, no, it's okay. There's no stress. If I was to draw my normal sine graph, it would look like that, right? I would go, it would be something like this. I'm not going to draw the whole graph. Okay, at 0 degrees, it's 0. At -90, it's 1. At 90, it's -1. No, that's wrong. I've gone the wrong way. I'm really making a mess of this question, guys. There we go. And it's not even a pretty curve. There we go. That's our normal sine graph. Okay. So that's what my normal sine graph would look like if I was drawing it. Okay. So that's just y is equal to sine x. If this point over here, I'm going to make it a bit bigger so you can see. If I normally am on 0 for y is equal to sine x, but now I'm on 1/2, that means that I have moved my graph up by 1/2, which means my shift has been 1/2 up. And so that's why my Q value is going to be 1/2, because I've shifted my graph up 1. Okay, so I'm going to have y is equal to a sine x plus 1/2, because I've shifted my graph up 1. Normally, sine would be on 0, 0, but now it is on 0 and 1/2. So I've shifted up 1/2. Hopefully that helps clear that up a little bit. Okay. The next thing we need to look at is we need to try and find our A value. Now, our A value we can find by taking our max minus our min, dividing it by 2. So for our A value, we can say, well, our maximum is 1.5. Our minimum is 1/2. And we're going to divide that by 2, -1/2. So we land up with A is equal to 2 over 2, which is equal to 1. Okay, but this is where we need to be careful. So in the last one, remember I said, is my graph going up, was my graph going down? And my graph was going up. So that was A was positive. Do you see how this red line kind of looks like it's opposite to what I drew with my blue line? It's like it's doing something funky. We're getting a DNA curve happening where we don't want a DNA curve, right? It's because from my y-axis, my line is actually going down. And because it's going down, that means that my A value is negative. Remember how your A value in parabolas tells you if it's a happy parabola or a sad parabola, and in hyperbolas it tells you which quadrant you're in. It's the same idea. Your A is telling you what this graph is going to look like. So because my graph is going down, my A is going to be negative, which means this 1 is going to be negative. And so my full equation is going to be y is equal to -1 sine x plus a half. So this is your amplitude, taking into account if I'm going up or down, and this is your shift. Hopefully that makes some sense. Okay, I'm going to give you one to try by yourselves. If you would like to take a screenshot of this, you're welcome to. And then we're going to zoom past some things. I'm going to zoom past amplitude and range here. We will talk about it more in COS, so I'm not stressed. And I think I'm going to scooch over our brain break for today because our time is running out. So the A is -1 because in my graph, I'm looking at my red line here, okay? And my red line, from the y-axis, my red line is going down. And because it's going down, my A value would be negative. If it was going up, then my A value would be positive. So in this one, it was going from the y-axis, it was going up. So my A value was positive. So if we have a look at this next question, for example, okay, from my y-axis, is my graph going up or is my graph going down? Yep, you can change the half to 0,5. Good, it's going up. Because it's going up, that means my A is going to be positive. Let's look at this one. From my y-axis, is my graph going up or is my graph going down? Down, which means my A is going to be negative. Okay. Cool. I know it's difficult to read these, especially if you're on a phone, so I'm just going to write the maximum and minimum points for you. So this here is -90 and -4, and this over here is 90 and 0. So you've got your minimum and your maximum. We know our A is going to be positive. Try and see how much my graph has shifted. And see if you can tell me what this equation is going to look like. Don't overthink it. Don't panic yourselves. And if you're wanting to try my sneaky trick method, that little line that I've drawn for you is the line you care about. Yes, Lindero. Yes, I'm shifting down by 2. So my Q is -2. Great start. Great start. Okay, now we're going to need to find our A value. Good, guys. The things you're writing are excellent. Shifted down 2. Good. And remember, this is the first time you're finding an equation from trig graphs. It's easier from here. Now we need to find our A value. So for our A value, we're going to take our maximum value, 0. We're going to subtract our minimum value, -4, and we're going to divide it by 2. And our A value, we know that A is going, you see how it's going up? This red line's going up, which means our A is positive, which means it's going to be y is equal to 2 sine x minus 2. Did we get there? Did we make some progress? Tell me how this question went. Tell me that looks like a light bulb moment, which I love. Nice. Good job, guys. It's okay, Canva. It'll come together. Okay, so for A, if you take your maximum and you minus your minimum, don't forget to have that in brackets because it's going to have to become a positive, and you divide it by 2. So 0 plus 4 is 4. 4 over 2 is 2. And then we look at the direction. So because this line is going up, our A is positive, which means that's positive 2. Okay. Let's try sneak in. Let's try sneak in another one. Nice job, guys. Getting there, getting there. Good. Okay. So this one, we've already established our line is going down, which means we know we're going to have a negative A value. Okay, we're going to have a negative A value. Let's look at our max here. Our max, negative 90 and 4. Our min, 90 and 0. Think about how much we've shifted and then try and find your A value. Good. You didn't fall for my trap, Kevin. Yes. I thought I was going to have people fall for my trap, Yolanda.
People never disappoint. They're so good. I'm happy they're not in the trap, guys. Well done.
I thought you guys were going to fall for my trap because I was going up in 2s and not 1s, but you didn't fall for it. Yeah, Rangani, you can. Let me quickly pop up there. Okay, let's have a look at some of these answers that are coming in. So, yes, we have shifted up by 2. So we know our Q value. So y is equal to A sine x plus 2. Excellent. Then we have to find our A value. So for our A value, we're going to say our maximum minus our minimum divided by 2, which is 2. Now we have to think, okay, but it's going down, which means A is negative. I see some people fall for that trap though, which means my equation is y is equal to negative 2 sine x plus 2. This has to be a negative because of the error. That was the sneaky one here.
Well done, guys. We did corrections and now we know.
Oh, sorry, I'm so sneezy. I know it was nasty. I'm sorry. Let's try one more. If you need a screenshot, this is your time. Thank you. And then let's try one more question. Okay. From the y-axis, am I going up or am I going down? Okay, I won't help you anymore. I won't say anything more than what I've said. I'll give you your maxes and your mins. I'm only giving that to you. It's not because I'm helping you. It's just because I think it's difficult for some people to see. If you're not on a laptop, or a computer, if you're on a phone screen, it's difficult to see these numbers. So I'm just putting those in for those people who can't see. And I would like this full equation, please. And then I'm going to throw you into your quiz.
Guys, I'm using the line, you know, the dotted line that teacher Jenny taught me so that I don't go into the trap, guys.
The dotted line, I know it seemed confusing when I first brought it up, but it is actually super helpful. It tells you exactly what
does.
your Q value is, and it helps you
Yeah.
see what A is. So look at the purple dotted line I've just put in, because that's going to help you find your Q value, guys. Because a lot of the Q values coming in are wrong.
Yeah, because without that, guys, I was getting always the Q value wrong. So with the dotted line, at least now I know what to do.
Okay, let's have a look. So how much have I shifted from 0? I've shifted down to -1. Okay, that's a -1 there. That's where I'm crossing my y-intercept. And so my Q value is -1. If you said -0.5, I understand that mistake but I'm jumping in twos. I've got -2, -4, -6. But if you said -0.5, I understand where that came from. So we've got y is equal to a sine x minus 1. That's our first start. Okay, and that's why that dotted line is helpful. That always tells us where our Q is. Then to find A, we're going to say A is equal to our maximum minus our minimum. Don't forget your brackets over 2, which is 4 plus 6 over 2, which is 10 over 2, which is 5. We know that this arrow is going up, which means A is positive. And so our equation is y is equal to 5, oh goodness, sine x minus 1. And that's our final answer. Did anyone manage to get this one 100% right? I'm very curious. Do we have any brain buffs out there? Ah, Josh. Oh, well done, guys. Yes. If you got the -0.5 instead of the -1, I'll give it to you because it was nasty. Nice job, guys. Well done. We are going to carry on with some trig functions next week. We're going to jump into cos, but for the moment, you are going to do a quiz on this. It's much easier because it's multiple choice. Don't panic. Just go through it nice and slowly. And I hope you all have a lovely, lovely weekend. And we will see you happily on Tuesday. But also just for those of you who weren't here when this lesson started, we are carrying on with lessons during the holiday. So that we will be here to do maths the whole time. And if you have any questions about that, let me know. But Yolanda, they're all yours. Get them into that quiz.
So there is the quiz, guys. Enjoy the quiz and enjoy your weekend. Study smart and all the best with your exams. Yeah,
a period is how long it takes for the curve to complete its full cycle. So in sine and cos, it's always going to be 360.
Zandisila wanted to know how can you get the dotted line? How do
the
you?
Purple line. So
yeah, the purple
basically,
line.
you want to find the center point. So you want to find the point that's right in the middle of the graph. You want to find the,
so
the
almost like where the graph is cutting the y-axis also in a way.
Yeah. And Paul, how can I help?
Hi, ma'am. Can you hear me?
I can.
Ma'am, I wanted to ask, when you're doing that calculator trick that you taught us, what would happen if the step was like irregular, like it wasn't a constant jump?
So the only time it starts becoming irregular is when we start having a b in our equation. When this dude starts popping up in our equation, which he'll start popping up next year, then that affects our step. And so then we need to talk about how that changes our calculator work. But if that b isn't there, then we don't need to worry.
Okay, thank you, ma'am.
Okay.
Hi guys. As for hopefully you got the link by now.
Zama, can I help?
Hello, ma'am.
Hi.
Can you hear me?
I can.
Okay, I wanted to ask, what's the difference between the soft bracket and the square bracket?
Okay, so the curved bracket means that it doesn't include that number, and the square bracket means it does include that number. So this is saying that I am allowed, it's allowed to be 1.5, and it's allowed to be 2.5. But if there was an asymptote there, so it's not ever allowed to touch 2.5, then I would have to have a curved bracket because I can't touch that number.
Thank you. Thank
Sure.
you.
No problem.
Adios, buddy.
Or Konisa, how can I help?
Hey, Mama, can you hear me?
Hi, yeah.
I wanted to ask,
Sudas, your sound is coming in and out.
is the point at the bottom always the maximum? I was
The point
saying,
at the point at the top is always your maximum, and the point at your bottom is always your minimum. So this will always be your
okay.
maximum point here, and that will always be your minimum.
Oh, okay. Thanks.
Samkelo, I'm not actually sure of the exact procedure you would follow with a sharp calculator, but I'll look it up this weekend and I'll come with it on Tuesday for you. Okay.
All the best, guys. Bye-bye.
Okay. Bye, guys. We're going to call it a